Okay, I'm going to attempt to do lab 29. So I'm going to go to draw and go sources. And I'm going to look for an AC voltage source. If you look, kind of got that a little wonky, so I'm going to hit escape so I can straighten it out. So I'm going to right click on it, edit it, and I'm going to change it to 25.2, which is what the output is, in 60 hertz. And I'm going to show you that in the drawing here in just a second so we can talk about what we're seeing there. As soon as I find the lab again, the pain of having too many windows open here. So if you take a look, you can see that I'm taking a 120 volt transformer and I'm stepping it down to 25.2 volts. So really my source is this side, and notice the center tap is to ground. I'm not sure what that's going to do here. Hopefully nothing. We'll find out, but I'm going to add these two diodes and the resistor in, and we're going to see what happens. So I'm going to come out of there, and again, need to have that drawing up on my other screen. I keep bringing it over here for y'all and losing it. So just a second to slide it back from whence it came so I can see. So I need 4001, so I'm going to say draw, add the components, add nodes, and that is the proper polarity. Add another one down here, that's what it wants to do. Then I'm going to add a wire to those two. And then I'm going to put actually let me undo that and I'll show you why. One of the things I found out, if you want to put something in the middle like this, it's best to draw a couple of wires, join those nodes together, and then draw. I'm going to add a 5.6K resistor. It's electrically the same thing, but it just works better this way. So I'm going to edit that, change that to a 5.6. I'm going to hit OK, and then we're going to draw the sources. We're going to add a ground right here, give it a path. And if you look, our simulation speed is fairly low, but if you look, do we have current flow yet? Let's look at current speed. Yep, and we can see that current alternating back and forth right here. And I'm going to right click here and say, actually, I'm going to put right here and say view and scope and see what we're getting, if anything. It doesn't look like anything. So give me just a moment to try to figure out what's going on. Okay, I added a ground here. And now if you take a look, we're getting our half-wave rectifier, which is what this guy's doing. So if you notice, the current is flowing through this resistor only every half cycle. So if we look at the current being created right here, if I go to view and scope, we'll see a full sine wave down here in the bottom right. But this is looking at what's going through that 5.6, and notice we're dropping the bottom half of that. We're making it more DC-like, because remember, DC, the essence of DC is, excuse me, let me back up. AC is anything that dips above and below the zero line, and obviously the waveform on the left is above only, so it is alternating DC, but the right-hand side is AC, alternating current. So we've made it a little more, and I didn't do the very first one, just the one in 4001. I think you could probably handle that. And I'm going to try the full wave rectifier to make sure it works and to give you some hints. But once I figure out these could be built, I'm going to let you guys do it on your own. So there's that one. And I'm going to pause the video. It seems like we got enough time, and maybe see if the full wave will work. Okay, so there's your full wave rectifier. Draw a little screwy compared to your lab, but it can be done here, and that's the most important thing. If you notice, frequency just doubled, and I'm going to show you that. I'm going to right click here and say view and scope, And you'll see that what we're doing is we're in essence taking the bottom negative portion of this wave and we're flipping it to the top. And that's what you're seeing on the left-hand side. So we have doubled the frequency and we've still kept it DC in respect to ground there, in respect to the zero, which I often refer to as ground, which I guess is really a fallacy. But anyway, this side right here is full DC because the zero line is that middle line right there and everything's above it. This is still alternating current. This is coming from right here, and this is coming right here, our output. So basically these are our input terminals on top and bottom. This is our output, and this is our ground reference. So we would be measuring a DC voltage right here on this this guy here, and that's alternating DC, but it's still DC. Okay, I added in our 10 microfarad capacitor there, and if you'll notice, we're still got a half wave coming out, but notice what's happened, or excuse me, we still got a DC coming out, but notice what's happened to it. It's a whole lot more above zero. We got rid of that alternating line, and I'm going to show you we did just by adding this capacitor, just by moving it down. Notice what happens. We're back to our half wave rectifier here. But as soon as I add that back here, look what happens. We become much more DC-like on our output, and we're maintaining a much more level DC voltage out of this than what we were. So it's pretty magical things can happen as we learn how to build a little power supply like this. So I'm going to give you a chance to experiment with it and see what you can come up with.